All right, so another football problem here. I have a quarterback who throws a pass at 17 meters per second, 29-degree angle, so he's throwing the football down the field to a wide receiver who just took straight off. It's called a go route. That means the wide receiver just runs straight. Okay. Now, if you don't know anything about football, the quarterback doesn't immediately get the ball and throw it. Okay, the quarterback has to get the ball. He takes a few steps backwards, all right, while the wide receiver starts running. So that it gives the wide receiver a little chance to go a little ways. So in other words, before the quarterback throws the ball, about 2.5 seconds passes. All right, so in our problem, before the quarterback throws the ball, 2.5 seconds passes. And then after 2.5 seconds, quarterback throws the ball 17 meters per second, 29 degrees. Ball goes up, comes down, and wide receiver catches it. Touchdown over Brook High School. Lovely. Now, here's the question that I want to ask. How fast, velocity of the wide receiver, how fast does the wide receiver have to run to catch a pass that this quarterback throws at 17 meters per second, 29-degree angle? If the quarterback, if the wide receiver basically gets a 2.5 second head start on the football, so he's able to run for 2.5 seconds and the quarterback throws it. How fast is he going to have to be able to run? Is he going to have to keep going? Can he run slow, fast? How does that work there? Okay. Now, you're going to need to know a few things to figure out how fast he's going to go. Just a thought here. Velocity of your wide receiver, this is constant velocity, is going to be how far he has to go divided by time. Now, the time it's going to take, delta x, right, how far he has to go, divided by, and I'm going to divide this into two things, time of the ball plus 2.5 seconds, right, because that's what the total time he has to run, 2.5 seconds plus the amount of time the ball is in the air. So if I can find the time that the ball is in the air and delta x, how far the ball actually travels in the x-axis, then I can calculate the velocity of the wide receiver. So we sketched a picture. Now we're going to actually write down everything we know about the projectile motion of the ball, because now I'm looking for how far the ball went and the time of the ball. So the velocity in the x-axis, here I have an angle, right, with a vector with an angle for my initial velocity. So it's going to be 17 cosine 29 degrees. Delta x is one of the things that I need, and time is the other thing that I need. So how long is the ball in the air and how far does it go? Y-axis, now, the initial velocity, let's do yi there, is going to be 17 sine 29. Delta y here is going to be 0. Assume that the wide receiver and the quarterback are about the same height, so it's all being caught on the same level playing field, if you will. Acceleration of gravity, negative 9.81 meters per second squared, and let's actually give a meters per second up there. Also note, positive initial velocity, negative acceleration, because the ball was going up and gravity is going down. And the two things I don't know here are time, right, which is one of my goals, and final velocity in the y, which I don't even care about here. Now, I don't have enough information to solve for anything in the x-axis, but I do have enough information to solve for time in the y-axis, right? I know three things, and I can solve for a fourth, and I'm going to need that time in the x-axis. So pick an equation here. It's going to be our favorite, right? It's going to be delta y equals VIT plus 1/2 AT squared. Plug in 0 equals 8.24 meters per second. That comes from this right here. So you plug this into the calculator, 17 sine 29, you get 8.24 approximately meters per second times time plus 1/2 negative 9.81 times squared. All right, so now I need to factor out a t, right? So 0 equals t bracket 8.24 plus 1/2 times my negative 9.81 t close my bracket, so t is going to equal to 0, and now I need to solve this other. 0 equals 8.24 minus about 4.905, 4.9 t, and that obviously comes from the 1/2 times negative 9.8. All right, so subtract my 8.24 to the other side. Negative 8.24 equals negative 4.9 t. T equals 1.68, approximate 1.68 seconds. All right, that's great. So now I know the time. Now I need to find delta x, how far it went. So in other words, now I know the time that I'm going to have to plug in for time the ball is in the air. This is how long the ball was in the air. But I also need delta x, how far the ball went. And that's going to be found from the x-axis. So now we can use this time that we found in the y for the x. So velocity in the x is going to equal delta x over t, right? So 14.87, I had already plugged that into my calculator and then wrote it up here for me to remember. 14.87 equals delta x, what I'm looking for, divided by my time, 1.68 seconds. So then you're just going to multiply both sides by 1.68 and come out with 24.98 meters. All right, now I know the two pieces, how far the ball traveled, how long the ball was in the air, where I can actually come and solve for how fast the wide receiver is going to have to go. Because remember, the wide receiver got a 2.5 second head start, if you will, before the quarterback threw the ball. So I need to know how far the ball went, how long it was in the air, and now I know those things. So the speed or the velocity here, the wide receiver is going to have to run at. He's going to have to cover 24.98 meters in a total of 1.68 seconds plus 2.5. So now that's just simple calculator work. You come out with about 5.97 with 2 sig figs. That has to become 6.0 meters per second. Is how fast the wide receiver has to run. All right, so now let's think, is this number realistic? 6.0 meters per second is around 13 miles per hour. The average human can run at a speed somewhere around 11, 12 miles per hour. And this is an athlete, we would assume, playing wide receiver, so he's going to be a little bit faster, right? So 13 miles per hour is a fine velocity. So 6.0 meters per second does make sense.